Hey everybody, so today what we wanted to do is design actually a new spool holder because quite frankly spool holders suck right now. So I'm going to see if I can help with that a little bit. So we're going to start with a triangle because triangles be good. Let's go ahead. Actually I'm going to delete that line because I don't like it. I'm going to go ahead and start right here. That is actually a bit too big. I'm going to take that down to 30. And I need the dimensions from there to there to be, I think it's about 1/7. There we go. Cool. Now we'll put that right there. That'll be good. And then we'll do a line like this and like this. There we are. There we go. So, what we're trying to go for is a spool holder that can both be mounted to a wall and stand. So, for that to be fairly reliable, it's got to have a wide base on both sides, but preferably not using too much material throughout this whole thing. This core size is chosen because that is the core size of a 3.5 kg spool. So we're going to try and get that all there. There we go. Cool. That'll be the baseline for this whole thing. I don't want it to be super thick, but I'm going to go for 15 because it's going to need some sideways rigidity. Actually, no, I was wrong about that. We can get to that from a different direction. So I'm just going to go for 10 so that we minimize it. And I'll show you a nifty trick here. So I'm going to go ahead and make our spool core real kind of spoke here. Get that center line right there, and we'll go 27. I think I'm going to have to go back into the other design too and expand that out because there's some things I want to do. And that needs to be 100 for the spool size. Okay, so that's good. Now I'm going to go back into that other design and widen this out so that there's a lip for it to catch against. There we go. Now I'm happier. That looks much better. Problem with this though, we want this to be along the base, otherwise we're going to have problems. So I'm going to actually change this up just a bit. I also circular designs are not very desirable because they create a weird situation where you have the sagging on the bottom that you either have to support or you have a skewed up piece. So I'm going to try to do a polygon here, right there, right there. There we go. And I want that to be an 8-sided. Because an 8-sided is one set up from a cube, and you can see right here, those are 45-degree angles, which are exactly what we want. Now I'm actually going to go back into the previous design because I completely forgot about this. Let's get that out the way we want it. There we go. I'm going to have to come back to that, but an octagon is very nearly a circle. And I want polygon. There we go. There we go. Now I'm going to delete that. I'm going to go from there to there. I might come back and readjust that again. Because why not? This is actually, there was a textured aesthetic that I wanted to do on this, and that gives me the excuse to do that. I don't like that. I want that to be about 25. Nope, 30. There we go. Oh, they did that to me. Okay, never mind. Let's dimension that. That'll be fine, and then we'll dimension that, which will be fine. Let's make sure those are parallel. Actually, no, they're coincident. Oh, right. My bad. There we go. I'm happy with that. I'm going to take that down to... Actually, I'm going to delete that because I want these to be dimensionally basically identical. 10's a lot. I'm going to go for 8. And if I'm being real clever, I'll scale that outer one down so that this is at the same distance. In fact, I'll do that. No, I'm not going to do that yet. There we go. Alright, now we're moving in the right direction. Now we got the thing. Alright, so when you have this printing, what I'm going to do is actually print it just like this. This way you have all the layers in line with the spool itself. And I'm going to extend that more because I'm sure that's wrong. There we go. In line with the spool itself. That makes it a lot easier, a lot more reliable, and you don't have to deal with any sort of silliness. Now, okay. We're probably going to have to make that smaller and create a wider lip on the other side. That way the spool can go on. But we'll come back to that in a moment here. The first thing I want to do is build the backboard for this sucker. The back right here, wall mounted, just like so. I'm just sort of scoping this out for now, and we'll see where we end up with it all. I want it to be symmetrical, so I'm going to go ahead and take this 150. Oops. 150, and we're going to go 2 distance. Can I go up 2 object? Yes, I can. Nice. Done. Cool. Covered for forever. All right. Now, here's the interesting thing. We don't want this to hang upside down, because if it was hanging in this orientation, you'd have screws up here, which means that this has a lot of leverage on those screws. So we actually want it to be pushing into the wall, and we want the most structural part down here to be the top. So in order to make sure everybody mounts it like this and we don't have any problems, I'm gonna just go ahead and kind of create some visual language to try to induce that idea. And I think I'm going to start, I don't want to put a top and bottom on here because labels be dumb, but we'll probably have to. Right here, this is the minimum distance between the edge of the spool and knot. So up here, I'm able to put in a rib that will give us the rigidity that we want. So I'm going to start with that first, actually. Yeah. Actually, if I was doing this rib correctly, I need to do this as like a 3-point construction. Plane through 2 edges, plane through 3 points. There we go. Now I'm happy. So let's go ahead and project up a couple of those details so I have something to trace against. And I don't really care about the side direction, but I do care about the total depth, because that has to be less than the radius. And actually, not measured from there, measured from... I'm going to eyeball it. There we go. Measure from there up to this. And, yeah, 140 will be fine, I think, on that. There we go. Again, just kind of laying it out here, so it's not the end of the world if it's not all perfectly symmetrical yet. Join those. Okay, cool. Now we have sideways rigidity on this thing. And the bottom, as viewed here, is actually going to be the top, so no one will ever really notice. And if I'm being real clever, I might turn that into like a shelf or something underneath there, so that you have like nippers that can be hung behind this spool. We'll mess with that a little bit later on, but before that, there's an error in this that will need to be addressed, because this mounts to the wall fine, but it doesn't actually stand fine. It's actually going to fall forward. It doesn't have a good center of gravity, and I don't want that. So we're going to have to take this whole triangle and move it down to one side there. Hopefully that's not a giant... it's going to be kind of a giant problem. I'm going to lock in that one. I'm going to delete this dimension. I'm going to delete that line, apparently. There we are, that's more better. I'm going to take this line, go here, there we are, And make those two coincident. Sweet. Now I'm going to recreate that dimension again. I'm sure that's too much, but we're going to live with it for a moment here. Then we move this around. There we are. How far is this? It should be a driven constraint, but I want to... 12. So, in order to fix my baseline thing, I need this to be 46. Oops, wrong one. There we go. There we are. Now that's all symmetric the way I like it. That looks pretty darn nifty. Except now, my rib is on the wrong side. Because I want that rib down at the bottom so that everything is as structurally sound as it can be. So I'm going to go ahead and kill the rib. And that axis. Delete. And we're actually going to put this back on the other side where it belongs. Okay, so now let's go ahead and sketch on that. And we're going to take, darn it. Project that, project that, project that, project everything. Just need everything all the time. Everything, everywhere, all at once. There we are. Okay. Now that is right there. And right there. And we're going to take that, make sure it's 140 away at least. Project the edge of this to make sure we've got good distancing. And then we're going to go ahead and take this and take that and go 140. Well, that's not what I want to do. Actually, that is what I'm going to do. I'm going to go back to the core because this means I've messed something else up. 200, there we go. There we are. Now my rib's a little bit more better. I'm going to make it fairly beefy because this is the only thing that is holding this reliably. Make sure that we're joining there, and there we are. We have a nice little rib. So now this will print on this edge. The rib will be fine. This edge will be fine. I need to clean that up a little bit more so that it's laying flat against the bed. But we have a good spoke here. The edge goes all the way out to there. Okay, good stuff. You only need 2 holes in this type of a mount because it's supported both directions by the wall itself. So you only need enough screws to provide really good strength in a single area. And quite frankly, if you have connection to a stud, you should just use like 1 screw, just enough to mount it to the wall because all the lateral support is already there. So there's not a lot to be gained with putting a ton of screw holes in here except to create more holes in your wall. I'm going to go ahead and dimension those independently from there. They're going to be biased slightly inward so that we have support over by the arm where it actually matters and closer to that rib. Because again, yeah, the outer edge just doesn't do anything, so what do we care? Come on, give me some dimensions. Okay. Then, on top of that, I want to countersink these holes just a tad, so that if you're using wood screws or something that doesn't look nice, they'll disappear. And they will end up looking nice. Plus, countersinking allows the walls to be further in on the screw, so there's not as much of an opportunity for something to break through, because the walls are supporting it better. Whereas if the walls are backed by infill, cracks are able to get started more readily. So if we just print this thing with really thick walls, we can basically have no infill, which will improve the manufacturability of this a bit. Actually, I'm going to take that in 3. Actually, I'm going to take that in 5. And then, again, to reduce cracks and make everything look better, we're going to fillet all of this just as much as we possibly can around these holes. Otherwise, you'll end up with all kinds of problems. There we go. And then we'll fillet the holes themselves, but I'm going to save that till the end. Okay. I'm going to change this backstop because it doesn't need to be that thick, and there's no reason to waste that material on it. There we go. 140. Actually, I'm going to do 130. This is going to create some weirdness, but I'm okay with that. There we are. Now, I want to kind of maintain our design language here. So, I'm going to do this and this. Make those 10. 20, I mean. Oops. 20. There we go. There we are. Now we're kind of following constructive paths with all this. Actually, I need to undo that because I need to mess with this sidewall some more. The thing I forgot to do is add this line out here, right there. Make sure it is coincident with this. And now we need to extrude that. There we are. Now we don't have a little weird spot in the back. But again, now I can come back and do my chamfers. I'm going to give that 5. Again, just trying to clean it up a bit. And then modify my chamfer. There we are. And right there. And actually right here as well. See how far we can go with that. How far will it allow us to go with that? Let's go 15. I'm going to try to make it a little bit smaller so that it doesn't jack up all this. I'm actually going to remove that one. We'll come back to that. There we go. Now we have a spool holder that can be mounted to your wall, and it prints on its edge right here. We'll have to settle that inside of the slicer, but that's okay. Now, here's the thing. I don't want a solid piece right here because that doesn't look very interesting. Oh, the other thing we gotta do. I want this to be a polygon and inscribed just like that. Then we'll do dimension here. This only needs, oops, not what I want. So parallel, there we are. And then this needs to be coincident right there. And actually, I can do something really interesting here because I can have that align with that, and that align with that, and it's not exactly what I was going for. Can I? I don't like that very much. So the issue is that it doesn't create symmetry and the function that I want. So I want the best of both worlds all the way through, all the time. There we are. So we're going to do that. And we're going to make that 5 because it doesn't need to be much. Although I kind of like it to be symmetrical. There we go. There. Now that should prevent the spool from falling off the edge. It does kind of mess with some things that I was trying to do, but I think we'll be okay. We also need to dimension this smaller, like I stated before, just because this is not going to let the spool onto it. But now you have a spool holder that can stand horizontally or hang to a wall. And while this is, the base is narrower than that, I do want the base to continue to be narrower for, again, saving material and looking better. But it's not necessary. But the center of gravity when the spool is mounted on here will be over the base still, so you shouldn't have a tipping problem, but that is an issue. We gotta kind of address that. So, but I'm gonna circle back. Well, nuts. Darn. If I do that, darn, that doesn't look good at all. I don't like it at all. Oh, also that screw hole is right behind the pin, which means it's going to be stupid hard to put in. So let me spread those out some more so that it's actually easy to access and mount this thing. There we are. That's much better. Now you can actually get in there with a drill to put this together. All right, so that's the way I want that. That's the basic shape and form. Let's see. What else is going to bite us on this? I want to fill this in completely, so I'm actually going to add some more chamfers to this, because this rib, as a rib, I don't like. There we go. That looks better. I like a block back there more than the alternatives. And again, leaves the spool lots of space, looks better. Regular ribs are just ugly. And plus, it creates more structure, and yeah, it looks better. But since I can do that, let's see here. The rib. There we are. Let me rename this. I want to make that smaller, shallower, -1. That way, you don't have a block and then the rib. It's just a nice, solid piece back in there. Much better. And it's right next to the screw, so the screw would have to go through all that to tear out, which is all better. Okay, that's good. And yes, we've got a nice, decently wide base on this. I might adjust it and move this up a little bit, actually. Let's take that direction a bit. There we go. We'll put it dead center. Dead center-ish. Now, the other benefit of this is that the fact that this is laying flat, this is going to be angled forward, which means that the walls are actually stronger because you have a greater thickness inside of there. And it's not running straight along the layer lines. Like if it was printing just like this and the layer lines were going straight perpendicularly across that, they would split across there. But this way, the layer lines are going to be coming across at an angle, so they won't actually tear through as easily because it's got to tear through so much more and across layers. So that radically improves the structural integrity of the part. I still hate this. So we're going to, while maintaining our design language here, I'm going to create a triangular slot in this that will remove material, which is not really what you want, but it'll break up that giant mass of stuff. And in fact, if I was being smarter about this, I'd turn this into like an up arrow, which I like even more, because it doesn't create a stress concentration there. Let's go back into that sketch. I'm going to go ahead and create some slot designs here. Create slot right there, slot right there. Now remember, here as I'm working on this, down is up. So we gotta work around that. I'm gonna make this actually 5. And let's dimension this as 5. Let's do a radius 2.5. Let's get those all concentric with each other. Actually, not what I wanted. Nuts. Waive the concentricity constraints. Darn. Okay, let's just go full clean sheet here. Create slot. There we go. I'm going to make that 8. And then I'm going to create another new slot. And the challenge that I'm having here with this is that I got to put it... Oh no, this is going to be okay. We're going to survive here. There we go. Let's get this dimensioned. There we go. There we go. Yes, I should make this symmetric, but I don't care right now. That tip of that arrow is right in line with that hole, so I'm going to pull that back some. Right here, right here. Okay, fine. I'm paying for my laziness already. Let's go right here and right here. Oops. There we are. That's better. And this is now in line with the other hole, so we'll adjust that too, so that it doesn't ruin our part. There we are. And now this breaks up that big old open space that's so ugly. And puts a really nice -5. Actually, I'm going to take this all the way back to -8. That way the back wall is 2 millimeters thick, which is perfect to have basically solid wall. There we go. And now people know how to update this, and also probably how to kind of feed it. We may end up making this base wider. I want to print and test it to see how easily it pulls over, but really we're kind of thinking of this as being also like mounted to the desk, so I'm not too concerned about it. And again, I really want to kill these 2 holes too, because they're just not necessary. I think if we went to one hole and changed slicer settings so that it's solid through that hole, that'd be fine, and there's nothing else weird that has to be done. And then it's perfectly structural all the way through. Because 2 screws, you don't need 2 screws. There's no structural reason to need 2 screws here. Except to hold the part, to distribute the load across the screws. But even when like this is hanging on the wall, the top screw is having full pull out. So you still we only need 1 hole here. I was an idiot. We don't need 2 screws. It's just a need for symmetry, and that's dumb. Screw holes are not necessary at all. We don't need that one. Done. Okay, now, again, I have this weird sort of big empty space, but I'm actually going to fix that because triangles be awesome. Now, let's go ahead and delete this chamfer, and I can go ahead and create a chamfer right here. It's about 50 big, or 100 actually. There we go. Actually, I should only do that at 50. I'm going to do it at 80. There we go. And now you can see that this design kind of leans everything towards the hole, which is very useful. And because of that, I can now suppress this arrow. I'm not going to delete it because who knows what mistake I made. But see how it's minimalizing towards triangles? That's kind of what we want. And again, since we're taking off this chunk over here, I can probably lengthen it out some more again, or take this and actually make that 170, like so, and that way this can go closer to center, and then this can be defined by this. Oh no, let's go, I want the coincidence. There we go, that will fix that. And now I can make that chamfer bigger. And now we still only have 1 hole because this is the top. This is the spot that's where it's mounted from. And again, since we're increasing this angle, this whole strength of it gets better. So when you optimize, everything can get better all at once. And quite frankly, if it doesn't, you're doing something wrong. Oh, that's starting to look really good now. I'm quite pleased with that. And this is supported by thicker material right there, but since we make it thinner, the walls themselves are the main structure, but it's diagonal, so it prints better. All of this is coming together pretty darn well. That pretty much structurally is fine for now, I think. For the outside, I want to change the structure of it a little bit. So you don't want to do through holes. You never want to do through holes on 3D printed parts. They're a terrible idea because they're a waste of print time and material and effort, and they create an aesthetic problem, all the problems with that. But a texture would be really cool on this, and I think what I'll do, I'm okay with the hexagonal shape, but I don't want to emulate other designs. So I think actually I might lean on a triangle. I kind of like to do something with scales. Let's create a poly. Actually, that's how to get it done. I'm going to go ahead and create a polygon, an inscribed polygon here. I want it to be 10, and I want it to be 3-sided. Oh, I want it to be 5. There we go. Okay, now this thing, I'm gonna dimension from here to there. Yeah, that'll work. Grid driven. Oops. There we go. Yeah, 10. I want a good solid border around the outer edge of all this stuff. Okay, and then 10. And now I'm going to rotate this around because I want this triangle to be the opposite from the main. Because number one, that's just more interesting. Okay. Now I'm going to extrude that just a hair into it. -2. Actually, -1. -1, yeah. Textures you don't want to make super deep. Alright, so I'm happy with that. Now I'm going to pattern that. And I'm going to use features. Take this, and then I'm going to go from here and there. I'm going to go 10 at 20 spacing. That was not enough. Oh, it's an extent. I don't want an extent. I want spacing. There we go. 20. Okay. Oh, darn. I made a mistake. Although I kind of like that. I'm going to run with it. Let's go 20. Oops, too many. Now the great thing about these triangles is that they're kind of low effort computationally, so I don't have to worry about a bunch of slicing on this. And there is our pattern on that, which looks kind of nice, but now we don't want to clean it up a little bit. I don't want it to be that ugly. So I'm going to go around and create this nifty little border all the way around to there, and from there to there. And now I'm going to go from here to there, to there, to there, to there, to there. And now, through the magic of constraints, and then dimensioning, I want this to be 10, because 10 is kind of the magic number. That's too much. Down at the end it's going to look weird, so I'm going to make that 7. There we go. That's much better. The proportions are much better in that regard. 8 might actually win out, though, now that I say that out loud. Now that I'm seeing it here. I'll mount it up. We got to close this off. I don't really care too much about it. This might bite me later on. Don't care. Gotta select that sketch. No. Okay, fine. Get all these chunks and pieces here. You know what's really going to hit me on this is when I decide I want full triangles rather than that little cropped triangle. I kind of like the cropped shape right now, so I'm kind of going to keep it. 1. Actually, 1. There we go. Okay. There we go. There we are. That looks pretty good. That's a kind of a nifty diamond pattern. And yeah, we'll imprint the logo on it at some point there, and I will clean up those. I'll get to it, don't worry. By golly, that's a new spool holder.